Alright, so we just took some time to investigate some collisions and saw that in each of these collisions, the momentum of the two objects together was conserved. Okay, and this is a really important concept, and it's a pretty cool one because it allows us to make some really interesting predictions. Okay, and so we're going to see how we might apply it in a couple problem-solving situations. So here we have a box sliding on a surface, and it's going to collide with another box, and we don't know how fast that box is going, and they're going to collide and stick, and they're going to move to the right with a speed of 1 meter per second. Then it asks us to find the velocity of the second box before the collision. So we can use conservation of momentum here. And what we're going to do is make before and after charts. Okay, or these like momentum bar charts. And so we have an 8 kilogram object, and then we have one slightly smaller with a mass of 4 kilograms. Okay, 8 kilograms, 4 kilograms. And so, as we talked about before, one thing that's important here is that direction is important. Okay, we're going to say that to the right is positive, and while this question is unclear, we're going to assume that this first box is already moving to the right. So if it has an initial velocity to the right of 5 meters per second, it might look like something like this. And then after they collide, they both have a velocity to the right of 1 meter per second. Okay, and then we want to find out how fast this box was going before they collided. Okay, well, we can find the total momentum of our systems, okay, by adding up all of our momentums. So in this case, 8 times 5 is going to give us 40 kilogram meters per second. This will just be 4 times v, because we don't know what v is. It's 4 kilograms. Then 8 times 1 is 8 kilogram meters per second. And then 4 times 1 gives us 4 kilogram meters per second. And so 8 and 4 makes 12. And then we get 40 kilogram meters per second plus 4 kilograms times v is equal to 12. So from here we're going to subtract 40 over. Okay, we get 4 kilograms times v is equal to negative, we're going to say 28 kilogram meters per second, and we'll divide over the 4 kilograms, and we get velocity to be equal to negative 7 meters per second. So what this tells us is that this 4 kilogram box, while this one was moving 5 meters per second to the right, it was moving 7 meters per second to the left. Okay. Okay, so here we have another one involving some figure skaters this time, and they're sliding across the ice together to do a jump. And the male skater is going to toss the female skater forward with a speed of 8.6 meters per second. And the question is, how fast is the male skater going afterwards? Okay, so we have 82 and 48. Okay, and let's see. So we have a velocity here before for both of them of 7.4. And then afterwards, the female skater has a velocity of 8.6. We don't know the velocity of the male skater though. Okay, so 82, so mv plus mv equals mv plus mv. Okay, 82 times 7.4 plus 48 times 7.4 over here, 82v, and then plus 48 times 8.6. Okay, so go ahead and solve for the velocity of the male skater. So you multiply them all together, we'll combine these, We get 962. The next step would be to subtract 412.8 over to the other side. When you do so, we get that 549.2 is equal to 82V, and then we divide by 82. Okay, and we get V is equal to 6.7 meters per second. So that tells us that the male skater is traveling 6.7 meters per second after the throw, and he has transferred some of his momentum into the female skater, and now she's moving faster. He lost some momentum because of it, and now he's moving slower.